We have spent a fair amount of time talking about containers so far. Containers are so important because of their different characteristics and how those characteristics allow us to do different kinds of analysis. When we looked at sets, you may want to reflect and ask yourself, what is the principal purpose of a set? Why do we have sets? You may remember, of course, that sets have two important characteristics. One, unique items within the set. That is, whatever value you have, it will never be repeated in the same set. And the other, order doesn't matter. So it's like arbitrary order. Now, presumably, as we've said before, Python may be ordering the items in a set according to some internal optimization. But as we also saw in class, it's possible to see the same set represented multiple and in several different orders with no apparent rhyme or reason. What we need to understand is simply that the order doesn't matter in a set. So what is a set good for? You might want to pause this video and ask yourself this question because it's a good quiz question. What do we actually use sets for? And the answer is membership. We use the sets for membership to see if something's there or not. That's what we used for the spell checker, and we might use it for any number of other operations in which we're just interested whether the data contains a value, whether a particular value is represented within the data. That would be a reason to use a set. And following along that concept, we have a number of methods that are available to sets. This is one of what I call the power tools. It's something that takes care of something that we might have done through looping, we might have done through 4 or 5 statements, we're going to be able to do in one statement. The first is the set operations. Set operations allow us to see what's common, what's different, what's collected in more than one set or more than one structure. In this case, we have 2 sets, and the sets do share some items, but not others. Why don't I add one more here? So you can see each one of the sets has 2 items of its own, but they share 3 other sets. And we're going to use this as an illustration to show our first method difference. So what's the difference between X and Y? It's A and B, and A and B are in a different order because, of course, this is a set. So A and B are unique to X, and they're not available in Y, and this is the meaning of difference. We could reverse the two, of course, and we should see the reverse, the 2 items that are in Y that are not in X, and sure enough. So what does this allow us to do? Well, you might consider what you would have to do if you did want to see what was common between 2 sets, or what was maybe in one set but not in the other. And this does come up reasonably frequently when we're just doing basic operations. Well, difference would be the way to go. Even if you had 2 lists, you might want to just convert one to a set to see a difference. In this case, we don't actually have to do more than convert the first one because we need to be able to call the method. The other item, the other container that we're comparing to can be a list or some other container, even a dictionary keys. And so all we need is for the the container upon which we're calling difference to be a set. Let's go back to working just with sets, and let's look at a couple of other methods that are available. Okay, here we have the intersection method, which we're calling on X to see where the 2 meet. As long as I know that there are some items that are common between them, I should see those common items in the intersection. This is what's common between 2 sets. And then finally, we have our union, and union should give us, well, you could imagine what it might give us. it's a set containing all items. So this would be one way to get one set to update with the items in the other set, so that we have one big set which contains all of the items in both, of course eliminating the duplicate items that we found. So where might this be useful? Well, if you consider that occasionally we are running with two lists or two sets where it's important to know where they intersect or where they differ, then these comparisons make a lot of sense. Obviously, we could do this in 3 or 4 lines with looping, but it'd be a lot more efficient to do them with a set, in part because a set is optimized for membership tests, as we mentioned when we first brought sets to your attention. Take a look at this. Imagine we have a list of valid email addresses and also a list of email addresses that have come in. And we basically just want to see which email addresses, and so we could think of valid as being like a whitelist. I don't know if you've heard of whitelist. A whitelist is a list of approved values. With email addresses, it would be email addresses that are seen to be valid. For example, you may remember in the old days they had email systems that would allow you to keep a white list of email addresses, and if one came in that wasn't from those, someone would have to actually apply to be placed on your white list. This was a spam blocking technology. Well, obviously, we could go through and loop through each one and then loop through each other one and see which are the same or which are different. But fortunately, we have these terrific methods. What we're going to want to see with the 2 valid addresses and with the 2 addresses that we see in the test group is which addresses are approved, that is, they're a member of the whitelist, and which aren't. And we do that really, really easily with intersection and difference. So we can see that tester has an address that's on the whitelist. That's the first one you're seeing. And we got that by saying intersection. What's common between tester and valid? And then we also saw which email address in tester was not approved, that it's not a member of the valid set. Of course, this may remind you very much of the spell checker. It's the same concept, and sets are perfect for this purpose. And I should say, the reason we didn't use this when we were doing the spell checker is that I wanted you to keep track of which line each spelling mistake was on. So that had to be done in a more or less event-driven way. Although I guess it might have been possible for you to take each line and convert it to a set and then run a difference on it. But I felt that the looping within looping was a good exercise.